Alright, so here we are in the second lesson of 5.1, and I get to share with you one of the most awesome things about natural logs in terms of derivatives. The reality is a lot of times you can simplify logarithms before taking the derivative, and it ends up super simplifying the entire process. And so I'm going to jump right into an example of that. We will say if g of x is the natural log of something terrible, of 2x plus 3 cubed over x to the fifth, then find g prime of x. Alright, so they give us a function, they ask us to find the derivative, no big deal, we just have to take the derivative. Please take a minute to appreciate how horrible this is. Right? Think about how you're going to do this derivative. You're going to have to do its natural log, so it's going to be 1 over this, and then chain rule, times the derivative of this. Right? That's hideous. You're going to have 1 over that basically times a chain rule that has, times a quotient rule that has a chain rule built into it. It's going to be awful. But, what we could do is we could recognize, hey, can't I use the properties of logarithms to just rewrite g of x? Since this is the natural log of something over something else, can't I say that this would be the natural log of 2x plus 3 cubed minus the natural log of x to the fifth? And like in one quick step, the quotient rule is completely gone. Even if I were to just stop here, I would just have to do the derivative of this and this, which is, like two little chain rules, not too big a deal. But we can do better than that. Because both of them has an exponent with it, I can use the properties of exponents to bring that, the properties of logarithms to bring those exponents down. I can do even better and write this as g of x equals 3 times the natural log of 2x plus 3 minus 5 times the natural log of x. Please note, I'm writing g of x equals, and part of the reason that I'm doing that is so that I remember that I haven't taken the derivative yet. For as much as I've done some neat math tricks, I haven't actually taken a derivative yet, right? So at this point, I'm finally ready to take this derivative. I'm going to take this and get g prime of x is, now this would be 3 times, now I couldn't completely simplify it. This still has a chain rule with it, right? This is the natural log of 2x plus 3, so the derivative of that will be 1 over 2x plus 3, and then the chain rule says just multiply by 2. Minus 5 times, and the derivative of natural log of x is 1 over x. There is no chain rule here. If there was, you'd multiply by the derivative of x, which is 1. Doesn't really do anything. And we're more or less done. I just need to simplify a little bit. I could put the 3 and the 2 together as a 6 on the top, so that'll give me 6 over 2x plus 3 minus 5 over x. And that answer's pretty good by me. You guys know me, I'm always going to be a fan of simplifying further. So one thing I will say here is that you could get a common denominator. And it's worth mentioning it for practice. To do that, you'd multiply the first one by x on the top and the bottom. So if I just put, times x here, times x up here. On the other one, if I've already got 5 and x, I'll need to multiply by, the 2x plus 3 on this one to the top and the bottom. If you do that, you'll get your common denominator. So let's see, what would we have? This would be 6x over x times 2x plus 3 minus 10x plus 15 over x times 2x plus 3. Sorry for that messy 5 up there. There we go. Important thing here to remember is that negative has to get distributed to these things. So the final answer, you'll end up with something like negative 4x minus 15 all over x times 2x plus 3. And now again, I'm happy enough with the top answer. This is the derivative. It works. This one is better, particularly because if I were to ask you a question like, where does this thing have horizontal tangents, it's nice to have things in factored or simplified or common denominator forms. So this has all been just one example of how you can simplify a natural log problem before you take a derivative. I'm going to show you one more of those before we move on to the last video in this series. This one I would kind of recommend that you do on your own if you're following along. Find f prime of x if f of x is the natural log of the square root of x squared plus 1. Right, so we want to find the derivative of this thing. So I'd encourage you to think about how could this be simplified before you attempted to take the derivative. So again, if you want, try that one on your own. So what I'm effectively going to recognize is that a square root is basically a half power, right? And I mean, you guys already sort of don't like taking derivatives of square roots. Like I get that. So really, this is a fantastic opportunity for us to take that half power and bring it down. And there is now no square root part of this problem. Like the square root's gone. We can just take this derivative now. F prime of x. Note, I do still have to do a chain rule. This will be 1 over x squared plus 1 times the derivative was inside, so times 2x. Right? At this point, I'll recognize that the 1/2 and the 2 from the 2x are opposite, so those will cancel with one another. I will be left with f prime of x equals x over x squared plus 1. And there it is. We're done. So main idea of this video, just if you're taking the derivative of the natural log, always look at whether or not it can be simplified before you actually try and take that derivative.